In this lesson, I'll show you 4 examples on how to write equations for the standard enthalpies of formation. Question 1 reads, write equations for the formation of A, magnesium carbonate, and B, glucose. Include the value of the standard enthalpy of formation for each equation. Let's start with part A, magnesium carbonate. Magnesium carbonate is formed when you take magnesium metal, combine it with carbon or graphite, both of which are solids, in addition to oxygen, which we will denote as O2 given that it's a diatomic molecule, and it's a gas. This eventually forms magnesium carbonate. And what we want to do is balance this equation so that we have 1 mole of magnesium carbonate. If you have to use fractional coefficients, that's fine. Magnesium is balanced, carbon is balanced, but oxygen is not. But if I multiply O2 by 3 over 2, multiplying 3 over 2 with 2 cancels out the 2's, leaving you with 3 oxygens. This is the correct balanced chemical equation. The question also wants us to include the value of delta H formation. That can be found in any index. The index that I'm using is shown right here, so you would include delta H and this number right here. That's the answer to part A. Now let's move on to glucose. Glucose is made up of carbon, hydrogen, and oxygen. Carbon in its natural form is a solid. Hydrogen is a gas, and it's a diatomic molecule. Also, oxygen is a gas. This yields C6H12O6. If only nature was this simple, we wouldn't need photosynthesis to make glucose. All we would have to do is combine these elements together and eventually would form 1 molecule of glucose, but that's not the case. Let's continue. We now need to balance this, so I'll put a 6 here, I'll put a 6 here. Now we have 6 carbons, 6 hydrogens, and a 3 in front of the O2. That balances the chemical equation perfectly. Its standard enthalpy of formation was found to be negative 1273.3 kilojoules per mole. And this is the reason why we want to make sure that this is 1, because it's per 1 mole of glucose. In question number 2, they want us to write the formation of NaCl and PbNO3 subscript 2. Let's go ahead and do that. Let's start with NaCl. We have Na plus Cl. Na is a metal, Cl is a gas, and it occurs in nature as Cl2. This forms NaCl. What I have to do here is put a half in front of the Cl2, and this will correctly form NaCl. According to the index that I have, its delta HF is equal to negative 411.0 kilojoules. And finally, we have lead nitrate, this compound. This is composed of lead, Pb, plus nitrogen, a diatomic molecule, plus oxygen, forming PbNO3 subscript 2. Balancing this, we don't put anything in front of N2 because there are 2 on the right side. There are 6 oxygens on the right side, so we put a 3 here, and that's it. Its standard enthalpy of formation, according to the index that I have, is equal to negative 451.9 kg per mole. And there you have it. That is how to write equations along with the standard enthalpies of formation.